Write the general solution of a differential equation and use indefinite integral notation for antiderivative. Use basic integration rules to find antiderivative. Find a particular solution of a differential equation. To find a function bf whose derivative is small f equal to 3x squared, you might use your knowledge of derivative to conclude that the bf is equal to x cubed, because when we differentiate the x cubed with respect to x, we have 3x squared. So the function bf is an antiderivative of small f. A function bf is an antiderivative of a small f on an interval I when bf prime x equal to small fx for all x in interval. Note that bf is called an antiderivative of small f rather than the antiderivative of small f. To see why, observe that bf1 equal to x cubed, bf2 equal to x cubed minus 5, and bf3 equal to x cubed plus 97 are all derivatives of small f equal to 3x squared. In fact, for any constant c, the function bf equal to x cubed plus c is an antiderivative of small f. The theorem of representation of antiderivative. If bf is an antiderivative of small f on an interval I, then g is an antiderivative of f on the interval I. If and only if g is of the form gx equal to big fx plus c for all x in I, where c is a constant. Using the theorem, you can represent the entire family of antiderivative of a function by adding a constant to a known antiderivative. For example, knowing that differentiate x squared with respect to x equal to 2x, you can represent the family of all antiderivative of small fx equal to 2x by gx equal to x squared plus c, where c is a constant. The constant c is called the constant of integration. The family of functions represented by g is the general antiderivative of small f, and gx equal to x squared plus c is the general solution of the differential equation. G prime x equal to 2x is a differential equation. Because a differential equation in x and y is an equation that involves x, y, and derivative of y. For example, y prime equal to 3x and y prime equal to x squared plus 1 are examples of differential equations. The graph of several functions of the form y equal to 2x plus c are shown in figure below. For example, the c is -1. If c equal to -1, meaning that the y-intercept is at -1. If c equal to 0 for this equation, meaning that the y-intercept is 0, y equal to 0. And for c equal to 2, the y-intercept is at 2. When solving a differential equation of the form dy dx equal to fx, it is convenient to write it in the equation equivalent. The general solution is denoted by y equal to antiderivative of small f with respect to x equal to bfx plus c, where the small fx is integrand and the dx is variable of integration. bfx is an antiderivative of small fx, and c is constant of integration. This expression is read as the antiderivative of small f with respect to x. So, the differential dx serves to identify x as the variable of integration. The term indefinite integral is a synonym for antiderivative. The inverse nature of integration and differentiation can be verified by substituting big f prime x for small fx in the indefinite integration definition to obtain integrate big f prime x with respect to x equal to big fx plus c. If integrate small fx with respect to x equal to big fx plus c. So, differentiate with respect to x on integration of fx with respect to x is equal to fx. Thus, two equations allow you to obtain integration formulas directly from differentiation formulas. Describe the antiderivative of 3x. First, we use constant multiple rule. We factorize out the 3, and we can write the x as a power form, which is x power to the 1. And we use the basic integration rule, where the power plus 1 and divided by the power. And we simplify the answer. So, the antiderivative of 3x are of the form 3 over 2 x squared plus c, where c is any constant. Note that the general pattern of integration is similar to that of differentiation. Original integral, we write, integrate, and simplify. You have already seen that the equation y equal to integrate the fx with respect to x has many solutions, each different from the others by a constant. This means that the graph of any two antiderivatives of small f are vertical translation of each other. For this example, the figure here shows the graph of several antiderivatives of the form y equal to integrate the 3x squared minus 1 with respect to x equal to x cubed minus x plus c, where this solution we call as general solution. So look at this figure. The brighter color curve are general solution. Each of their antiderivative is a solution of the differential equation dy dx equal to 3x squared minus 1. In many applications of integration, you are given enough information to determine a particular solution. To do this, you need only know the value of y equal to big fx for one value of x. This information is called an initial condition. For example, in the previous figure, only one curve passes through the point 2, 4. To find this curve, you can use the general solution. Fx equal to x cubed minus x plus c is called general solution, and the initial condition. At this point, x equal to 2, y equal to 4. So we call initial condition big F2 equal to 4. By using the initial condition in the general solution, you can determine that big F2 substitute the 2 into x variable and equal to 4, and we solve for c. The c is negative 2, and we substitute the c into general solution to obtain particular solution. Find the general solution of b f prime x equal to 1 over x squared, where the x greater than 0. And find the particular solution that satisfies the initial condition big f1 equal to 0. To find the general solution, integrate to obtain big fx equal to integrate the 1 over x squared with respect to x. We can write the 1 over x squared as a power rule form, and we use the basic integration rule, where the power is plus 1 and divided by the power. And lastly, we obtain general solution. Using the given initial condition, bf1 equal to 0, we can solve for c value. We substitute the 1 into the x variable in general solution and solve for c. After we obtain the c value, we substitute the c value into the general solution and we call particular solution. You can look at the figure here. The curve of the brighter color are general solution, where the darker color one is particular solution.